This presentation is made for beginners who knows very little about iPulse. It is a light controller developed from iCore. I'm going to give you some instruction about the features of iPulse. I'd like to say thank you for joining the presentation. I'm Kyle, Technical Support Manager at iCore. It is my great honor to be here in front of you. Today, I'm going to explain features like constant current control, overdrive, accurate and fast timing control, LED protection, and multi-strobing. iPulse is a controller that derives more than 100% performance from LED based on iCore's analog circuit and FPGA design technology. It is quite different from the controllers that comes with LED. They can be suitable for normal applications, but some applications where very intensive lighting is required need specialized controller like iPulse. What makes iPulse special will be explained in the following pages. There are two types of method to drive LED: constant voltage and constant current. Before telling you which one is better, let me briefly tell you how LED works. First thing you need to know is that the current through LED determines the intensity from LED, not voltage. As you can see the left graph, the intensity of LED is almost linear to the forward current. This means doubling the current almost doubles the brightness. But when you see the right graph, it is a current versus voltage curve for general LED. The current does not linearly respond to the delivered voltage. It shows small change in voltage causes large change in current. There are factors to cause some change in voltage like voltage drop from cable or temperature change. So constant voltage type of controller cannot guarantee to keep the current, which means there could be difference of light intensity between LEDs. But constant current controller keeps the current through LED no matter what because there is a feedback circuit inside to deliver appropriate voltage of the current. That's why constant current type of controller is superior to constant voltage and required in machine vision. The function of overdrive is very effective when capturing fast-moving objects with area scan camera. By shortening the pulse duration and boosting the current through LED, it is possible to acquire image bright and blurless at the same time. You might be afraid of that this overdrive could kill the LED because it drives LED greater than the rated current, but actually you don't have to be afraid. Main reason of damage of LED is overheating from LED. But if the pulse duration and the duty cycle are properly regulated, LED could cool down. iPulse has a function to limit on the duration and duty cycle based on the level of overdrive. Overdrive is a gift to those who wanna increase the brightness and remove the motion blur simultaneously. Let's imagine you are using area scan camera to capture very fast moving object. With continuous lighting, as the upper left picture, you have to shorten the camera exposure time to reduce the motion blur. But the problem is that the minimum exposure time of camera is relatively long. Because of the limitation of its image sensor, the minimum exposure time you can set is around 10 microseconds. With pulsed lighting as the upper right picture, now you can adjust actual exposure time by changing the pulse duration. problem of motion blur has been solved, but the image is too dark. In this case, you have no option but slow down the speed of moving object. With overdriven lighting, it is possible to acquire bright, sharp, and beautiful image without slowing down the motion. As I mentioned in the previous page, adjusting pulse of lighting is the most effective way to control the brightness. Also, pulse of lighting can determine when to start exposure time. That's why accurate and fast timing control is required for pulsed light. When it comes to controlling timing, I'm pretty sure the performance of iPulse is the best compared to other controllers from different manufacturers. First, the pulse duration can be set 500 nanoseconds at minimum. In fact, it can be reduced to 200 nanoseconds at certain conditions. It is such a great benefit if you want to freeze the image. Rising time of pulse is also important. To obtain bright and sharp image, it is necessary to produce stiff rising pulse. The rising time of iPulse is less than 500 nanoseconds. Trigger delay is just 0.5 microsecond, which means iPulse is able to instantly turn on light right after getting triggers. As I mentioned earlier, iPulse is equipped with a function to protect LED. When overdriving, LED is put at risk of overheating, so the pulse duration and duty cycle should be limited to let LED cool down. iPulse automatically changes the limitation on the pulse duration and duty cycle according to the scale of overdrive. For example, if you set the intensity of pulse 100%, you can input 10 milliseconds and there's no limit on the duty cycle. If you set intensity 500%, the pulse duration is limited to 2500 microseconds and duty cycle is limited to 4%. If you set the intensity 1000%, the pulse duration is limited to 100 microseconds and duty cycle is limited to 1%. That means there is no more protection when there is more protection when overdriving more. So you are free from damage on LED when overdriving. The sequence function from iPulse is to turn on light of each channel sequentially upon the trigger input. As you see the left picture, there are serial signals coming into iPulse. As user set channel 1 lights on first, and then channel 2, channel 3, and channel 4 lights on in serial order, and then repeat again. The right picture shows how different lights give different images. A number of different measurements may be needed on an individual product. This can be achieved by acquiring multiple images with a single camera using several lights under different conditions, like angle or wavelength. iPulse can trigger the lights at different intensities in a defined sequence. This can eliminate the need for multiple cameras, saving both on cost and space. This video shows how multi-strobing works with line scan camera. iPulse lights on side light and coaxial light and backlight, switching alternately. In image buffer, the line captured by backlight is stored on the first row, and then the line captured by coaxial light is stored on the second row, and the line captured by side light is stored on the third row. After scanning, you need to split the image into three using software. Then you can obtain three different images just scanning once. This table shows full lineup for iPulse. There are a lot of iPulses with different number of channels, different output current. First, you need to check how many lights are needed per camera. Basically, you need one or multiple controllers per camera because the controller doesn't support independent triggering except IP2P2S200A or B. Using 4-channel controller with 4 different cameras may be limited. Second, check if the camera is line scan camera. If so, using these controllers can be limited because its switching frequency is low. If the camera is line scan camera, you can use all of iPulse. And then check the current output between continuous current and burst current. Burst current is more important. iPulse is not designed for continuous lighting. There are some controllers that has same current for continuous mode and burst mode. It means these controllers don't support overdriving function. This tree could help you about how to choose a right controller. iPulse can be categorized into some groups depending on whether it is for area scan or line scan, or if it is for low power or high power, or if overdriving is required or not. Okay, that's it. Now hopefully you understand iPulse. If you have any question, please email me, then I will answer as soon as possible. Thank you for listening. Bye.